Hello. Our group's name is Galactic Guinea Pigs, and we will be exploring planet Galaga.
We traveled 40 light years in 7 weeks to conduct one big mission.
Planet G is the sixth planet and one of the largest planets in the TRAPPIST-1 system. Although it is in the habitable zone, the distance from the TRAPPIST-1 star has made the planet extremely icy over time.
My name is Migdalia. I'm in Team A, which is physical properties, and I'm going to be talking about the magnetic field and atmosphere of our planet, as well as one of the technology pieces that we'll be using.
My name's Chelsea. I'm also on Team A with Migdalia. I'll be talking about volcanic activity on our planet and also the plate tectonics.
And I'm Lila, also part of Team A, and I'll be discussing ice and subsurface oceans.
So this molehill machine called the molehillinator is going to be used to dig into the surface of our planet to collect ice samples and to also store equipment.
So our other tech is not as cool as the molehillinator. You can find all these things on Earth, which makes it easy for us. So we have a weather balloon that will help us test and observe the atmosphere, a seismograph to help us learn about plate tectonics. And then we have two different drones. One is an underwater one, which would help us if we found a subsurface ocean, and a regular drone that will help us take pictures and observe the landscape. So a lot of the surface looks a lot like Antarctica, nothing really special. Unfortunately, there's no weird ice age creatures or penguins whatsoever, but we did find a way to drill into the surface. So we manually decided to make weak points into the ice so that our drill can go into the surface easier. If you can see on this diagram, it is of Europa, which is a moon, Jupiter's moon. And this can kind of give you an idea of what we were looking for in terms of the subsurface oceans. So we wanted to collect samples of our ice, and we brought coolers in order to store them. And also we brought extra jackets and heating pads to make sure we stayed warm while we were going down there. It was all smooth sailing until about 4 hours in, when we had finished collecting our samples, and our machine was efficient, but almost too efficient because water started coming up along the sides of the drill. So that means that we hit the subsurface oceans, which was great. However, we had to manage and get around making sure we didn't drown the machine and us inside, which would be really unfortunate. And since we had our underwater drones, which I mentioned earlier, we were able to deploy them into the ocean and take temperatures as well as get a sample of the water. But we didn't put them too deep because we didn't want to lose the drones. So it was just really good to know that we could find subsurface oceans on this planet.
So as we know, planet Galaga is a few billion years older than planet Earth, but it is also slightly more massive, which means that it is likely to still be cooling off. The planet's interior cools off through volcanic activity, where hot gases such as carbon are released into the atmosphere. Since we arrived on the planet, we saw many volcanoes on the surface, but we also confirmed the existence of plate tectonics using our lovely little seismograph as shown earlier. The volcanoes were truly a sight to see, as even though our planet was extremely cold as the coldest temperatures found on Antarctica, the volcanoes still release very hot magma and air. We came to appreciate the existence of volcanic activity on planet Galaga because without it, there wouldn't be a greenhouse gas effect that helped warm our planet to the point where we could explore it. Further into our trip, though, unfortunately, one of our drones broke, the drone that was supposed to take aerial photos, so we weren't able to capture photos of these beautiful volcanoes. This photo right here is an example of what it would look like. And we were also unable to confirm the existence of volcanoes on the dark side of the planet either. At least in the end, we were able to discover icy volcanoes and active plate tectonics, though.
Building off her comment about greenhouse gases, I'm going to start talking about the atmosphere first. And our planet's atmosphere is mostly made of oxygen, carbon dioxide, and hydrogen and other greenhouse gases emitted from volcanic eruptions. And we know that our planet, we found out that our planet also has a carbon cycle because carbon is usually found in rocks and oceans, and we have both of those on our planet. And so we do have an atmosphere, but it's slowly stripping away because it's so thin. And with the magnetic field connecting to the uh, greenhouse gases and carbon cycle, we have found that the core convections um, happen because of the heat within our planet. And we checked the solidified magma to as like another piece of evidence because like as you can see in the picture, they will make like a pattern and point in the same direction. So that was also a clue of our magnetic field. And the last clue of our magnetic field was our rotation period, which is 12.35 days. And we found that it was fast enough. And we also figured out this rotation period through the use of transits.
I'm Mariela, and I'm on Team B, the Search for Life.
I'm Hannah, and I worked alongside Mariela to search for life. When we arrived on Galaga, our mission was to search for life. After years of living in my parents' basement, watching unsolved mysteries, and reading conspiracies on Reddit, I have really high hopes of finding life. Oh, yeah, I also studied some science stuff at Wellesley for a few years, which also gave me a little bit of information that not sure if I believe, but it's there. After all, we might even run into members of the Galactic Federation on our trip. It's really exciting stuff. We will spend most of our time searching for life near the volcanoes and beneath the ice in the deep oceans.
There were a lot of really cute plants near the volcanoes. The majority were pretty small, resembling shrubs and ferns. Some volcanoes had more plants than others. When volcanoes erupt, it can be very destructive. So we assumed the volcanoes with less plant life probably had recently erupted. It was kind of scary to be this close to volcanoes, especially because we had no idea which ones were active and which ones were dormant. But it was still really cool to get to explore them, even though we were fearing for our life. The samples we took from near the volcanoes and beneath the ice revealed an abundance of single celled organisms and little microbes known as extremophiles. These are microorganisms that survive extreme weathers, either warm or cold. We obviously couldn't really see them until we got back to the lab. So when we put the samples into the microscope, we were very surprised to see these interesting looking microbes. We weren't expecting to see any large animals, but I was kind of hoping a dolphin or a penguin would be waiting for us when we got there.
Unfortunately, we did not find any evidence of intelligent life on planet Galaga. This was incredibly disappointing because the few days leading up to our trip, I kept seeing so many of my Twitter followers tweet about the Galactic Federation. This was a huge disappointment, and I feel lied to. We searched high and low and came up with nothing. While hanging out on the ship during a much needed break, some of us definitely needed to freshen up, if you know what I'm saying. Anyways, we're on the ship when our satellite picks up a distress signal. It sounded like a message from another spaceship, but we were unable to make contact back. It was all so sudden and unexpected, I had to pinch myself to make sure I wasn't dreaming. On our return to Earth, we contacted the other space explorers, and none of them admitted to sending a distress signal. This will be an unsolved mystery, and it's possible we may never know who or what sent the signal. We're still left with the burning question of if there's other intelligent life out there. We think that this distress signal may be our first sign of evidence.
Hi, I'm Madison.
And I'm Dina, and we're part of Team C, which we will be discussing the time capsule.
So, the top of the time capsule consists of 3 parts which connect to a base that will be inserted into a layer of bedrock. Beyond the smooth, slightly curved exterior is a second layer of interlocking vessels, which contain the time capsule's contents. Because of the variation in surfaces, it is hoped that the ice will further secure the time capsule in place over time. In order to attract attention, the time capsule will be tall and reflective.
We decided to use drones to search for an area to place the time capsule. Since we knew that there were volcanoes on the planet, we wanted to avoid being too close to these areas. Within a couple of days of sending out our drones, we found a large expanse of icy terrestrial land and rode out on our rovers to test the site's stability. Once we confirmed that this was a good location, we prepared to drive the time capsule out to its destination. And while we were assembling the time capsule, the lighthouse component brought back memories of home since I'm from an island where we have lighthouses. This kind of brought me back to reality, and I realized that everyone who we left on Earth would be significantly older by now, even though we were still so young. Being around all this ice also made me think about global warming and the rising of sea levels on Earth. Would my hometown even be around when I returned, or would it have washed away into the ocean? I'm happy, but also fearful about returning to Earth because I no longer know what it will be like.
It feels colder than I imagined it would be. 7 weeks, it seems so short, but I know that when I return to Earth, my home won't be waiting for me. As I stare into this vast expanse of ice, nothing to distinguish Earth from sky, I wonder how my parents are doing. They didn't want me to take this job. Assembling the time capsule and contributing to this mission is important work. I know it is, but it's lonely. The one thing that gives me comfort and motivates me to return home is the thought of my nephew. He's only 6 now. Anything could happen, I suppose, but I like to think that when we finally touch back down on Earth, he will be there with a hug and a smile like usual. For longevity and variety, our time capsule contains physical and digital copies of the following documents: an outline of our solar system, including the history and fate of our sun and the Earth, as well as a description about what we know about exoplanets. For life on Earth, we included a timeline of human history and arts, as well as social justice and the progress that we hope that has been made in our time away. Each of us has also included personal messages.
Unfortunately, we are sad to inform you that one of our crew members slipped on ice during our expedition. During the final days, we had to return to fix an anomaly on the time capsule, and in our rush, Madison slipped and fell into a coma. We decided to leave her body on the planet as an example of the average human being, so we buried her below the ice next to the time capsule. We thought this would be for the best given all the work she put into making the time capsule perfect, and we also didn't want to fly back with a body for 7 weeks. The messages in this report were recorded shortly before Madison's death.
In the end of our trip, we were able to make amazing discoveries and contributions to our understanding of exoplanets and prospects of life outside of Earth. We are deeply saddened by the loss of one of our teammates, Madison, but we are sure that she would be proud of the life she lived. Perhaps she will relive the life of Captain America and reawaken from her coma once again in the future. Again, we are also saddened by the fact that our aerial drone malfunctioned and could not explore the dark side of the planet. So we hope that one day we will return to our beloved planet Galaga, or in fact, we invite you to visit planet Galaga instead. Thank you so much for learning about our expedition.